Okay, let's get into it. Okay, so first, relational logical operators. So I'm mixing in you telling me what the definitions are and what the symbol is. So this first one, what's the definition? Yep, so just checking, is x greater than y? Second one, with your fingers, draw out what the symbol is for this one. Less than symbol, cool. All right, greater than or equal to. What would this one look like? Greater than, followed by how many equal signs? One or two?
One.
Just one equal sign here, okay. What does this symbol mean? Okay. This one, if we were to draw out, yeah, two equal signs. And why is it not one equal sign? Okay. I still see in people's code, sometimes they ask, like, why is the else statement never running? And it's because they have one equal sign in the if condition, which is always going to be true. Right? So if we're actually trying to check if two things are equal, two equal signs. And then this last one, not equal to, oh, oops. All right, exclamation point equals. Got trigger happy. All right, any questions on any of these? Relational operators? Okay, and the reason why they're called relational operators is it's saying how the two items on either side of the symbol relate to each other. So is the item on the left greater than the item on the right? Or are they equal? It's kind of the relationship between two. That's why the operator itself is called a relational operator. Okay, so practice. How would we read this first one in English? Yep, and is that true or false? Okay, second one? Okay, less than or equal to 5, is that true or false? Okay, for these next three, we'll pretend x is equal to 10. Is x greater than or equal to 10? Because of the equal sign, if we didn't have this and it was just greater than 10, then what would the answer be? False. Okay. All right, how do we read this one? Yeah. Essentially another way is x different than 8. Is this true or false?
Sure.
Okay. And then this last one?
False.
Cool. Any questions on any of those? Cool. Okay. We then move to logical operators. So logical operators are used to combine two different normal conditions into one big condition. So the example we used was to check if a user was a teenager. And there are two things we did. We checked, is age greater than or equal to 13? And then what does this symbol mean? And is the user's age less than or equal to 19? So in this example, if age is equal to 11, is that greater than or equal to 13? Okay, so that's false. And then is it less than or equal to 19?
True.
True. So we have a false and a true. And what does this come out to? False. Okay. And we know that because 11 isn't a teenager, because it has to be between 13 and 19. All right, is 20 greater than or equal to 13?
Yes. True.
And is it less than or equal to 19?
False.
So what do we get?
False.
Okay. Last one, is 13 greater than or equal to 13?
True.
And is it less than or equal to 19?
True.
Okay, and what does that give us?
True.
Cool. And in this example, 13 is the only one that counts as a teenager. So you essentially need everything. If you're using and statements, all the subconditions have to be true. So putting it formally into a definition, true and true, what does that come out to?
True.
True and false?
False.
And then false and true will also be false. False and false?
False.
Cool. Any questions on and? Okay. The other symbol, does anyone remember what this symbol means? Or. So we have age is less than 10 or age is greater than 65. If either of those statements are true, then the overall statement is going to be true and we'll give the user a discount. So 8 less than 10, is that true or false?
True.
And greater than 65.
False.
Okay. And true or false, what does that come out to?
True.
Cool. 67 less than 10,
False.
greater than 65.
True.
And that comes out to.
True.
And then 45 less than 10,
False.
and 45 greater than 65.
False.
And that gives us,
False.
cool. So two groups get discounts. If the age was 8 or the age is 67, then we give a discount. And it kind of speaks like English, right? As long as one of them's true, then the overall condition is going to be true. Putting it into the table, true or true?
True.
True or false?
True.
Okay, false or true will also be true. And then false or false?
False.
All right. Any questions on and or, the logical operators? Okay. So these would be the kinds of problems that you would see on the midterm, something that combines both relational operators and logical operators. The answer for each of these is going to be either true, false, or mistake. So first part, how would we read this first condition?
X is less than 1.
Okay, and what are the values for x and y?
3 is less than 1.
Okay, so is 3 less than 5, true or false? True. And then is 3 equal to 5? So we have true or false. What does that come out to?
True.
Cool. Do people see how we broke down the problem into the two subparts? Then we got the true or false, and then we kind of just knew from our table and the previous examples what that should be. Okay, this one, how do we read this?
True. X is not equal to y.
Okay, so is 3 not equal to y? True. All right, this one looks very similar to the first bullet point. So x less than y, we said that was true. X equal to y, we said that was false. So we have true and false.
False.
False. So the only difference between the first bullet point and this third one is the logical operator between it, and versus or. Yep. All right, how about this one?
True.
Yeah, so you can do like addition in the condition statement. So we're saying x plus y, 3 plus 5, that's equal to 8. And is 8 greater than or equal to 8? And it's true. Okay, last one. What would the answer for this one be? Yeah, so this one's going to be an error. So we have put in mistake on the exam. And what's the error here?
You have the x on the right side.
Yeah, so each of these expressions on either side of the logical operator are their own condition. So x greater than 2, that's going to be true. And then the computer is going to see less than 7. And it's going to be confused. Are you talking about is y less than 7? Is x less than 7? Is some other value less than 7? So if we wanted to fix this, what would we put here? Yeah, and we'd say like and x is less than 7. Yep. But in this case, if it's like this, that would just be a mistake.
So you put mistake?
Yep, on the exam, and I'll put in the instructions. You'll either mark true, false, or mistake. Yeah. All right. Any questions for any of this?
So when consider selected exam, is it going to be like on a computer or like Canvas?
Two parts. So the first half will be on paper. So these kinds of problems will be on paper. The paper part will be like this, drawing a flow chart, debugging code, maybe one other thing I think of, but that will all be on paper. And then the second half will be on EdStem.
Okay.
But on EdStem, you won't have the autograder. So you'll have like the compiler, so you'll be able to run the code, but I'll be hiding the tests. So one way you could practice is even the homework problems you've already done, I would maybe try doing it again in the Scratchpad and make sure when you run it, then when you test with your inputs, like making sure it actually works. Cool. Any other questions? Okay. So that takes care of relational operators and logical operators. Next part is if, else if, else. So keyword, if we know our code is going to be doing different things, is going to be the keyword if. And then following that, we put parentheses, and then whatever condition we want. The condition must come out to true or false. And we've now had a lot of practice both with if statements and also while statements. They both kind of use this similar syntax. And then we have the curly braces. I've updated this slide to kind of very clearly show what code is going to run. So if we have code in this first if statement, that means condition 1 is true. Whatever we put in the parentheses came out to true. So we run whatever's in here, and then what happens to the rest of this big if statement block? It gets skipped. So if we run this first one, then we don't run anything after it until we get to like the very final curly brace, and then we continue with our program, right? So what that means, and I maybe should have taught it like this when I first taught it, when we have the else if and then the second condition, two things are actually true. Condition 2 is true. That one is kind of straightforward because if this is true, then we come into here. But the other part that was kind of implied, but I'm now going to explicitly call out, is that condition 1 is false. Do people understand why both of these have to be true for this else if statement to run? Like what happens if condition 1 is true? Yeah, if condition 1 is true, this runs, and then we skip these statements here. So the only way we can even check this condition is if condition 1 is false, then we'll check this else if statement. And if condition 2 is true, then we'll step into this code. Okay, that makes sense? Okay, so we're on to build on that one more time. If we had another else if statement, now 3 things are true. Condition 1 was false, so then we check condition 2. Condition 2 was false, so then we check condition 3. And now condition 3 is true, which is why we come into this else if statement. Right? And then once this one runs, then we skip the else and everything at the end. Which means that for our else statement to run, all of the above conditions have to be false. I'm still seeing people in their code, in their else, putting parentheses and trying to add a condition. Why do we not need a condition after the else statement? Yeah.
Because else just checks for all the remaining conditions
Yeah,
that don't meet the other conditions.
exactly. Like the else is just essentially using all of these other conditions. And if all these other conditions are false, then we have the else. So we don't need to put an extra condition after the else. It's just automatically gonna run if everything else was false. Yeah? Any questions here? Okay, so let's put it into practice. So for this problem, we're gonna assume that we're gonna have a variable called score, and we're gonna get input from the user. So the user's gonna type in some word like touchdown or field goal or extra point. And we wanna set up a big if else statement block that will assign points to the correct point value. So if the user were to type in something like extra point, we would want points to be equal to 1. Or it could be equal to 2 or 3 or 6 based on what the user types in the score. So we'll do groups of 2. You don't have to worry about doing the C in and C out. We'll assume that code is already there. Your job will just be to write down the big if else statement. You two want to work together. Are you okay going up here? You. Alright, are you okay here?
So the if score equals
Oh, yeah. Yeah, so the input will be like this range, extra point or whatever, and your job will just be saying what point value, what the variable point should be. I didn't know so we want point to be equal to 1, 2, 3, or 6, based on whatever the user So the user, yeah, the input is a string. Yeah, so the user might type in touchdown. And then we want point to be equal to 6. Or we want point to be equal to whatever, based on what the user.
so we saw like this.
You know right now?
Question, yeah. For now, we'll assume maybe points gets printed at the end, but for now we just want points equal to 1, 2, 3, or 6 based on. So we're gonna assign a value. Where the user's gonna tell you like touchdown, and then you would set points equal to 6. So again, the user might type in something like touchdown, and you should then set points equal to 6. So you're using the variable score, which is a string. The score will be equal to touchdown or field goal or extra point.
Maybe you don't want to put out there. Equal points to 1 in this case. You know what I mean? I think that's what I know what I said. I know he's right. What I said was the score, the output that he's telling us was the points. Yeah. And based on what they type in, it's telling them points. Wait, does that make sense? No, we don't have to do this. This basic.
Okay. Okay, let's bring it back and we'll set up the statement. So first off, what's the key word if we know our code's going to be doing different things? If. And what can we put in this condition? Uh-huh. Okay. Yeah, and so we could do, I'll keep it one word for the input. What might be the issue with this code right here? So we had set points equal to 1.
No parentheses.
Just 1 point plus points equals 1 plus, right?
Yeah, so we'll simplify this and pretend this is the first scoring play. But if we were doing it as a loop, then yeah, we'd do points is equal to points plus 1. What was that? Yeah, so if we wanted to print, we could print out after. Right now, this code won't even compile.
Yeah, because you only put quotation marks on it.
Yeah, so it's going to think extra point is a variable, right? But we're really comparing it to the word extra point. So if we want to compare it to the word and not the variable, we have to put quotes around it. Does that make sense? Okay. Okay, and then what's the next keyword we can do here? Cool. And here we can do, let's do the 2-point case. So what are our conditions? Let's look back here. Okay, so safety or conversion. So we can do score is equal to safety. And then what else do we need to do in this condition? Yeah, or, thank you, conversion. Right? Do people follow what we're doing with the or statement here? So we're saying if it's a safety or it's the conversion. Note how I, right, when I press enter, the brackets aren't lined up properly. Note how I always make sure everything's lined up before I actually go in and start typing what the code is. Just so that it keeps the structure very easy to see. Okay, so if either of those are true, then points is equal to 2. All right, what's the next one? Yep, so scores equal to field goal. Then points will be equal to 3. And then for the sake of time, I'll kind of copy this in. And we'll say score is equal to touchdown. Then it's 6. And then we wanted to do one more thing at the end. Yeah, so there's 2 ways we can do this. So essentially what we're saying is if the user hasn't typed in any of these things, it's not a valid football scoring play. So we could create like an entirely new if statement farther down and say like if score doesn't equal like touchdown and score doesn't equal field goal, right? And we do all 5 cases, then we could say it's an invalid scoring play. What's like an easier or faster way we could do that? Yeah, so with the else here, we know if the code comes to this part, this else statement, what do we know about all of these conditions? They must all be false, right? So that meant score didn't equal extra point. Score didn't equal safety or conversion. It didn't equal field goal. It didn't equal touchdown. So if we come here, then we know we can say, like, score is not a valid football. Yep. Okay, so let's do an example of, we'll see out points. Or actually, sorry, we'll see out points at the end. Okay, so if we're to run this, and we were to put in something like conversion. Okay, so the user's going to input conversion. So we come to line 10. What is being checked at line 10?
If score equals extra point.
Okay, and what does score equal?
Score equals conversion.
Yeah, so we're checking, does conversion equal extra point? Is that true or false?
Sure.
Does conversion equal extra point?
Oh.
Okay, so that one will be false. What line runs next if this is false? Yeah, so we skip line 11 and we come to 12. And we check, does conversion equal safety? False. Does conversion equal conversion? True. So we have false or true. What does that come out to?
True.
True. So what line runs next?
Yeah.
13, right? So because this overall condition was true, we're going to run 13, points is equal to 2, and then what line runs next? Yeah, so we skip everything else, and we come to 22, and we would print out points, which is 2. Yeah, do people follow that?
Yeah.
Okay, and then if we were to do something like, if we did like a soccer term, like goal, then what are we going to check? Goal is equal to extra point, true or false? So what line do we go to? 12. Goal equals safety, false. Goal equals conversion, false. So we go to 14. Does goal equal field goal? False. So we go to 16. Does goal equal touchdown? False. So we go to 18. And then what happens at 18? Yeah, so we don't have to check anything at 18. We know because everything else was false that we can just immediately go into 19. And so we can print out goal is not a valid football scoring play. Yep. Does that problem make sense? Okay. Okay. Sweet. So for the midterm, I was going back and forth on whether I'd allow this, mostly because I think if used incorrectly, it can be a detriment to some students, but I think if used correctly, it can be a big help. So I'll allow everyone to, I'll pass around these note cards. So an index card, you can write front and back on it, and you can bring it into your exam to use kind of as like a cheat sheet, like note thing on the side. 2 rules. The card must be handwritten, so you can't like, type it all up in small text and then print it and tape it to your card. The card has to be handwritten. And 2, you may not look at another student's card. So the reason why I'm letting you do this is that it's a very good study technique, where you can go and look through each of the slides and figure out what do you know super well and what do you not know that well. So if you know stuff like the less than symbol and the greater than symbol super well, you don't have to put that to your card because you already know that. But let's say you sometimes mix up the double equal sign with the single equal sign. Then I would put examples of those, right? Like 5 is equal to 5, that's true. Sorry, 5 is equal to 5, that's true. X is equal to 5, that assigns the value 5 to X. And you can put examples that you may be confused on your note card. And the benefit of doing this is instead of kind of like mindlessly going through the slides, now when you look through the slides, you're really trying to figure out what do you know and what do you not know super well. And the parts you don't know super well, you put down on your note card. And if you don't understand it because you don't get it conceptually, then you should come into office hours or send me an email, right? But if it's more of a memorization thing, you can put on me. Yeah, questions?
You can put like examples of code.
Yes, you can put examples of code if you'd like. So you can kind of choose how there's no restriction to what you can put on the card as long as you come up with it yourself and you don't look at someone else's card. Mhm. So yeah, that's for some students you learn better with examples. So if you just want to put all like coding examples on your card, that's totally fine. If you feel like you need to remember certain definitions or like tables, so there are a lot of tables and slides, put that down on your card. Yep. Any other questions on the note card stuff? If not, you can take one, pass it around. I would encourage you to try to make the card by Monday, because Monday we're going to be doing a practice exam in here. And for the practice exam, we want it to feel as similar to the real exam as possible. Right? So try making a card before Monday. If you find your card's not super useful for Monday's exam, then you can always go back and create a new card. Right? Cool. So building on that, I kind of have 3 main study tips for the midterm. Go through the slides as you make your note card. That way you're concretely doing something. You're not just mindlessly looking at the slides. You're actually like writing down stuff that you feel like you don't know super well. Make sure you finish all the problems in the labs and homeworks. So again, if you can do all 5 homeworks, you should be good for the coding part of the exam. I'm literally taking the same difficulty. I'm pretty much pretending like I'm writing homework 6, and I'm putting that on the exam, right? So if you feel good about the first 5 homeworks, you should be good for the exam. As I mentioned earlier, if you want more practice, I would take one of the past homework problems and try doing it in the scratch pad, where you don't have the auto grader, and just make sure that you can still get your code to work. Yep.
Flowchart's gonna be on the website?
Yeah, so that'll be on the written part for the paper. There'll be one flowchart problem. Yep. And we'll do practice on the next slide for that. And then the final thing is, if something doesn't make sense, come into office hours or email me. Okay? Okay. Any questions there about these slides or about the midterm in general? Okay. Okay, we'll go into flowchart. Okay. So for this one, I want everyone to draw their own flowchart. So for the roller coaster problem, we'd seen this on a homework, but essentially we're going to ask the user for their height, and we're going to do one of 2 things. We're either going to tell them to enjoy the ride if they're taller than 48 inches, or we're going to tell them that they're too short. And then regardless of which branch happens, at the end, we're going to tell the user to also have a nice day. So I'll make sure everyone has a piece of paper, and you'll be writing this one individually. You can maybe use the back side one. Use the back side. And you can use the back side of that other one. But, John, you can use the back side if you want, or on your notebook. Sorry, you can use it. There we go. Yep. And I'll take back to the next part.
Diamonds are like the if statements, right?
Yep. Essentially any condition, so we use it for while statements and if statements. Yeah.
What is the rectangle, again, I know they print out things, but instead of in
Kind of just like the English summary of what's going on. So in this one, we were just asking the user how many eggs do they have. So instead of saying like do C out and C in and define the variable eggs, we just summarize it. So ask the user how many eggs they have. You good here? You good here? Okay. I think looking around the room, people's flowcharts are looking like a lot better compared to a couple weeks ago. So I do see a lot of improvement there, which is awesome. Let's step through this particular problem. So flowchart, what's kind of the first thing that's going on in the problem? Yep. Ask user for their height. Cool. So again, like we didn't say like C in, C out, define the variable height. We're just giving the English summary of what's happening. So at the start, we're just asking the user for their height. And then what are we checking in the condition? Yep. So if height is greater than 48. The wording is kind of ambiguous. Even if you put greater than or equal to 48, that would be okay. So height is greater than 48. And if that's true, what do we want to do? Yeah, we'll say like print enjoy the ride. Otherwise, in the false case, yep, print too short. And then notice in the true case, the code comes back to the main code flow. The false case, the code comes back to the main code flow. So they both rejoin. And what happens at the end? Yeah, we'll say print have a nice day. Yep. Do people have any questions about any parts of this flowchart? Okay. I think looking around, I think it's starting to click, which is good. Okay. So final topic, while loops. What are the two requirements for a while loop? Yep.
Needs to be true at first.
Okay. True at first and then?
The variable needs to be able to change.
Yeah, so the expression will be true initially, could be true initially, but must become false at some point. That way we don't run infinite amount of times. And then what's the second part that must be true? Yep, but how do we make sure it's not an infinite loop? Yeah, the variable has to change. So both of these together prevent us from having an infinite loop. If you only had one of them, you would have an infinite loop. Because let's say we did, like we wanted to print something 5 times, and we said counter is less than or equal to 5, but we never increase counter, then the loop is going to run forever. Or if we increase counter, but our condition was 1 is less than or equal to 5, that is also always going to run forever. So you need both of them to be true. 3 of the examples we've seen. Microwave example, we have the condition be time is greater than 0, and we count down. So time decreases by 1 each time until time becomes 0. And once time becomes 0, that's how we end the loop. The password example. So we ask the user to try to get the right password, and we tell them to keep inputting a guess until they get it correct. Or if we're counting up with counter, counter is less than or equal to 5, and we'd increase counter by 1 each time. How many times would this loop run? 5 times, right? Because counter will be 1, then 2, then 3, then 4, then 5. And when counter becomes 6, 6 is no longer less than or equal to 5. So we wouldn't run a 6th time. Yep. Okay. So I'll move it back to you all. So while loop syntax, again, just while the condition looks a lot like an if statement. The difference is we don't have any sort of else if or else after here. The while loop this is all you need in a while loop. Okay, so in lectures before we'd done like print Morehouse 3 times. This time we're gonna let it be print Morehouse any number of times based on what the user specifies. So we'll ask the user, pretend there's like a C out and C in, we'll get the max number. First off, the first thing you should be considering, is this a counting problem or a validation problem? Counting problem. Why is it a counting problem? Yeah, we know exactly how many times this loop will run. So like let's say the user puts in 8 for max number. How many times will this loop run? 8 times. We'll print out Morehouse 8 times, right? So before this loop starts, we know exactly how many times it will run. So that's usually a good indication that our condition is going to be checking some numeric value with like a less than symbol or a greater than symbol. So with that in mind, what would our condition be for this problem? Okay, counter is less than or equal to max number. Okay, that's good. We'll come back to that. What comes in the loop here?
CL1.
Yeah, so we have the C out Morehouse, and then,
And then counter equals counter plus 1.
yeah. So we need to make sure we increase counter each time. I think this condition, especially in the homework, it was either lab or homework, maybe it was lab, was throwing students off, because I think we're used to seeing like counter is less than or equal to like the number 5, some literal number. But you can have like variables on both sides, right? And in this case, the variable max number is a number. Like it's just a number that the user has given us. So it's still essentially doing the same thing as saying like counter is less than or equal to 5, but now we can do it whatever the user tells us. So if the user wants to print it 1,000 times, this loop would run 1,000 times. Yep. Any questions on this problem? Okay. This is what the flowchart would look like. So we had the summary at the top for the first step, set counter equal to 1, and ask the user for the max number. The condition we're checking is just whether counter is less than or equal to max number. And notice that the arrows create a loop here. So we're going to keep looping until counter is greater than max number, and then we'll end. What would happen if we didn't have this step here, this increase counter by 1, and we only printed Morehouse?
It would print one time.
Not one time, it would print infinite times. Because the first time counter, like 1 is less than or equal to
It's
10.
always going to be less than max number.
Yeah, because if we never increase counter, counter is always 1, and that's always going to be less than or equal to whatever the max number is. So that's why we need to increase counter by 1. Okay, everyone good with that one? Okay, final problem I have for today, Wordle guesses. So this one, the user is trying to guess what the correct answer is. So we have the variables guess, which will be getting input from the user. And then we have this variable called answer that has the actual answer. First off, is this a counting or a validation problem? Validation, because we don't know how many times this loop is going to run. The user could get it on their second try, they could get it on their 10th try, their 20th try, we don't know. So we can't do something in the condition like while counter is less than 10. Because we don't know if it's going to run 10 times or 100 times, right? So instead, with validation problems, the condition should be true if the user's input is bad. Yeah.
With just like the word in general, would you do while and if, like while the guess is wrong, then you keep going, then if the first letter equals the first letter?
Yeah, so inside of the while loop, we're going to have an if statement to see whether the guess letter should be like red or yellow or green. Okay. So back to this one, the condition should be true if the input is bad. What counts as a bad input in this context? Yeah, anything that doesn't equal the answer. So how could we write that in code?
Guess does not equal answer.
Yes. While guess doesn't equal answer, that means the user has guessed incorrectly, so we're going to tell them wrong guess, try again, and then what should go at the end of the loop? Cn into what variable? Guess. Cool. So while guess doesn't equal answer, we want the user to keep guessing. And then once guess does equal answer, then this is going to be equal to false, and we'll continue with the rest of our code. So maybe we print congratulations at the end. Yep. So at the end, we could print like outside of the loop, we could print C out congrats. Why do we not need to put this in like an if statement to make sure the user guessed correctly here?
Because if they did it,
Yeah. Essentially, everything after this curly brace, we know that guess is equal to answer. Because if guess didn't equal answer, we would have run the loop again. Yep.
what if you put a counter on it to where it eventually stop, they don't never get it right?
Yeah, so in Wordle, especially because we're trying to limit it to 6 guesses, that kind of combines a counting problem with a validation problem. And so in that one, it would look something like while guess doesn't equal answer, and we would also need to check like while num guesses is less than 6. So we would need like both conditions to be true.
Put, like, see out, congrats, you get correctly outside of the.
So now we wouldn't be able to, because now we know at this point one of two things is true. Either the guess is equal to answer, or the user ran out of guesses. So outside now we would have to say like, if guess is equal to answer, then congratulate them. Or if num guesses is equal to 6, then we tell them, sorry, you lost. So yeah, in this case, if you have two conditions, then we don't know which of the conditions became false. Yeah. But for now, we'll just keep it simple and just say we were giving them infinite guesses. Okay. So flowchart, we ask user for the guess. While the guess doesn't equal answer, and that's true, we keep looping and we keep asking the user for another guess. In your Wordle project, to Ben's point, we would have more boxes in here. So instead of just asking the user for another guess, we would also give them hints about their guess. So we would like color their guess to be like green, yellow, or red, and we would put that in like an if statement in here. But the overall while loop would look at a high level, just like this. Any questions here? Okay. So final recap. Counting loops, we know exactly how many times the loop is going to run. So our condition is usually something that checks that value to make sure we don't run too many times. Validation loops, we don't know how many times the loop will run. And so the condition is just generally will be true if the user's input is bad. And we want them to keep making new guesses or new attempts. What's coming up? Lab 5. If you haven't finished Lab 5, come into lab today at 4 p.m. We'll be going over how to do Lab 5. If you haven't done Homework 5, I'd also encourage you to come into lab. We'll be giving support there. If you finished Lab 5 and Homework 5, then you're good. You don't need to come in. But if you haven't finished either of these, I hope to see you today at 4 p.m. And then midterm on Wednesday. Cool. Alrighty. Thanks, everyone. If you came in